You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session.
We have Tim with us today. Tim Weber, he's been in this industry for over 36 years. And if you want to know anything about bikes, just ask him. And then we got Tim Williams, also been in this industry for a while, going on 9 years. And we won't hold it against him, but he's a Penn State fan.
You'll accept it and love it.
Yeah, so we get calls all the time, especially our engineering group. We do 300, 400, 500 quotes a year, so we're used to it. But a lot of folks don't really know what's involved in the quoting process. So basically, that's what this is going to be about. What do we need, and what's involved in that whole process?
It's interesting because you could come to a company with a complete ready to assemble, ready to build project, or you could come with a concept design.
Right.
So really understanding, what's the supplier going to be looking for? What's the requirements? A lot of different details that go into the backside of the quote, especially if you're reaching out to multiple companies to make sure that you're comparing apples to apples when it comes to time to pull that trigger and make that decision.
All right, let's get started.
First couple of things we always talk about is the background on the part. How'd you get here? Is it a new project? Is it an existing project? Is it approved? Something you're trying to improve upon? Also, what's the end application? Where is this part used? We've been doing this. This is our 75th year, so we've got a lot of experience personally, and our company does in various industries. So these kind of things spur on other type of questions.
Yeah, absolutely. So giving the background on the project, if it's an existing project, you're going to be in the guts and details of the issues that you had. Some of those issues might be the reason you're searching for a new vendor, what the expectations are of that product, where does that product end up? What surface finish requirements are asked of it? Is it a part being assembled? Is it a part being hidden? What you're looking for, end goal, and the issues, form, fit, and function really of that product. So really detailing that out, defining it for the vendor that's really trying to quote that project really helps the vendor understand, what they're trying to do and the problem they're trying to help solve.
So some of the first questions that we ask, we talk about, material. With us in particular, it's mostly aluminum or sometimes a zinc alloy. And a lot of this information we're going to be asking is on the print. We would like to know, is there a print and a model? And then the weight of the part, if it's a model, we can pull that right off. If not, where do we get that information? What's the scope? What's the estimated annual usage? What processes does it go through? Does it get cast and machined? Does it go through heat treating? Any secondaries as far as powder coating? A big one's timeline.
It is for sure, and I think that's really the start and the driving factor when you get into the project. Starting what's the end goal in mind? When do you need the product by? Right. So working backwards from there and using a lot of that scope information to help build out and meet the expectations that the customer is looking for here. So if the timeline's, quick, hey, what strings can be pulled to get that product out quicker? Mm-hmm. What different processes can be looked at, different solutions for the problems you're having. And if it's, a little bit longer, are there areas we want to put more detail, more deeper dive or deeper scope into to find out some more information on if it hasn't been tested yet?
What does engineering assistance mean to the most folks?
Yeah, you hit on it earlier. Really getting involved in a project as soon as you start to develop maybe a concept. Having an engineer involved from the beginning, I think, really helps define expectations. So having engineering assistance could be different for different companies. A lot of what we see is really engineering is getting involved again on the design side, the manufacturability. You're going to come with a design. It either will or won't be manufacturable. Having engineering assistance available there helps break that down and say, okay, yeah, that didn't work, but here's 4 possible solutions to make that work.
You guys are talking about new projects, but what happens if it's an existing or like maybe it's an older part and you don't have updated models? Is that something you can still quote?
Yeah, that's a great question. If it's existing, you know a lot of the problems or the issues that you may have ran into in the past. Really the concerns of the parts that you're getting in. You can take any existing part, and there's technology out there now that we're able to scan it, really get a detailed model of what that part currently looks like. And if that part's currently working for you, you have that accurate model of what you need. So if it's a retool or if it's a current tool, you are able to develop a 3D model from that scanning technology.
Yeah, that scanning technology is it's pretty nice stuff. I mean, it's actually something you can use to not only do what Tim's saying is develop a model, but also to compare the model that you've got to the final part.
Yeah, and it's used a lot too on new product. Form, fit, and function to make sure it fits up to the model and the print that was originally developed.
So the answer is yes, absolutely yes. That's something that we do, and anybody should be able to help you out with as far as taking an existing part and getting it into a new tool. Quote turnaround time. So I'm gonna let you handle that one, Tim, because you've been diving into that for a while.
Yeah, absolutely. So again, it goes to the timeline of the product. So when you're trying to launch to market is really a big driving factor often, and really trying to get it back to the customer to make sure that the customer understands timely fashion what we quoted, how we quoted it, and making sure that it's lining out to what they want, and then also to make sure that they can compare those apples to apples. In a casting industry, it's a very, very custom quote. Especially if you're adding a lot of that scope that we talked about on the previous slide, there's a lot of time and effort that go into the different functions. If you're casting only, pretty simple, a quick turnaround on a quote, usually day or less type of thing. But if you're going, casting, heat treating, polishing, machining operations, coating operations, and it's not just those ops themselves. You got to think about all the molds and fixtures that go with them.
So typical, would 3 to 10 days be fair to say?
Typical? So typical, I'd say 3 to 10 days for sure. What we try to do is we target 5 days or less. Whether you're at concept stage or you're ready to launch the market, you don't have time to wait either way. You're trying to get what that cost is. If you need to make adjustments on the front end on the concept design, or if you're ready to go and pull that trigger to get it to market.
How do you build the quote?
You start with timeline. We look at the different ops that go into it, the different scope that go into it, the different types of operations that are needed to get that part through. And that information is walked through with the customer or prospect, to really make sure that, again, we're minimizing the cost back to the customer.
Okay.
How do you handle in-process changes or modifications during quoting process, or even maybe potentially down into production process?
So depending on what the change is, it may or may not have an effect. For instance, at one point on a particular product, it was a pressure type vessel, and they wanted to add in a pressure test. So we were able to just be flexible enough that we could do the pressure test while the part was being machined. So it changed the operation, but it didn't add any cost. So we're trying to figure out how to maneuver, how to be flexible with that change so that it doesn't affect what the customer's already got dialed into his formula. It just depends. But as soon as you're aware that there could be some sort of a change or some modification, and they happen all the time. Just that communication as soon as possible, getting with the foundry, I think is beneficial. And it's a kind of question. It's a good question that you should ask the foundry up front. What happens what happens if this, because especially if it's a new product. Not everything works as it's drawn up, and there might be some additional flexibility on some of the other parts that go into the assembly that made up. So it's just something to be aware of, but it's not that unusual.
What it really starts with in basic up front, which we're trying to do here, is develop a tool. So a casting tool that's going to cast your product successfully into the requirements that you're looking for. So Batesville Products specifically works on, and a lot of foundries should be using this, but not all do, is a finite element analysis. Really getting in to see, how that part flows the way it's currently set up and designed. how the metal flows, if there's any hot or cool sections, if there's any air entrapment, cores that need to be added, are there cooling areas or vents that need to be added? How do we make sure that that part is ejected and does what it needs to and part? And that's where the FEA starts, and that really gets you into that mold design.
We found it to be critical. It's a time saver. That's the other thing. It's a little bit of a few more dollars, but in the long run, it really pays for itself. And we do it on every single tool. Rather than fighting a problem over the years, it goes back to the FEA. Is that doable? It really affects your piece prices. If it's a high runner, how many cavities can you get in there? Hey, we want to put 6 cavities in here. Well, now you've superheated a section of the mold that maybe it's not going to work. So those kind of things, those kind of questions, that kind of information is important for the foundry to come up with a cost on it.
Yeah, and I think you hit on it too. It's key because the FEA is done before you even cut the mold.
Right.
So it's almost guaranteeing that you're going to be pouring the good casting the way you want to pour good casting before you even cut that mold.
Yep.
So where you're seeing the benefits of that are down line. You talk just about the foundry, but it ultimately goes all the way down line.
Yep. Whatever foundry you're using, they should be doing some sort of simulation, and they should share that with you up front. There's no reason not to.
And they're just cool.
Yeah, they are. They're very cool looking.
Yeah. So there's a lot of different items that go into making sure that we are developing an accurate cost and rate on the foundry side of things. So when we're just pouring the casting is what we're looking at here. So looking at a net weight versus gross weight, is there a multiple cavity? Is it a single cavity? The time that goes into that part, what ultimate metal is coming out in that net product, if you saw off gates and risers, that really is resulting in the casting that you're looking for, versus how does those gates and risers really affect your part. We also dig down deep into the specific types of equipment that are used for it. You go out to the market and look for casting equipment. There's all sorts of different technology, a lot of different avenues to really dive into when you're talking about a permanent mold casting, let alone other casting opportunities.
Correct. That's right. Machining calculating is very similar. Again, your machining cost is related to how complex the part is. The tolerancing, obviously, that dictates a certain amount of inspection. What type of equipment do you need? What type of tools do you need, not only to produce the part, but what kind of tools do you need to inspect the part? Is this something that can be done online? Is this something you want to have the operator checking, or is this something that you pull offline and have and take it into the inspection department and have them check tolerances and surface finishes and that type of thing? So the machining calculator, again, can be very simple. Drill tapped holes, or a lot of milling, cutting, grooves, boring, broaching operations. They can get very involved. So if the part dictates it, again, but it's one of those things that the discussion up front, can we cast something versus does it have to be a machined in feature? So that's a big driver of cost. And another driver of cost is the machining equipment. I mean, the feeds and speeds on machines today is just, it's amazing. And how quick you can get that tool changed, how quick you're making chips, seeing what kind of equipment they actually have and what kind of inspection equipment they have. Those are two important factors.
Yeah, it's not as simple as you think it would be when it comes to machining. You're not just taking a part over there and taking one tool. There's a lot of time and money that can be saved by the way you program it.
Yeah.
So,
guys, it looks like we've kind of come to the end. But if you have any more questions, please shoot them our way. We'd be happy to answer them. But thank you, Tim and Tim. This was great.
Thank you.
Thanks. You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.